Good evening, everyone. Hope I'm audible to everyone. Please raise your hands if I'm audible. That's great. Thank you. So firstly, I hope that each of you have had a lovely puja holidays. And today we begin a very crucial aspect in our course Eco Foundation. Today is the first class for the topic functions. Okay. Functions forms the foundation for most of the other topics in mathematics and as well as economics. Okay. So this is a topic which has to be mastered by one and all. Right? Chalo, without any more delay, let's get right into functions today. In order to understand functions as a mathematical concept, it's extremely important to understand the concept of relation. Now, relation does not mean uncle, auntie, chacha, tau, so on and so forth. This is mathematical relation. Mathematical relation क्या है? Relation is a correspondence between two sets. Okay. Namely, the sets are called domain and codomain. Okay. So any sort of a correspondence or any sort of a mapping between two sets is called a relation. So A, B, C, 1, 2, 3. This set where the mapping is originating is called the domain, and the set where the mapping is ending is called the codomain. Okay. Any sort of a correspondence is called a relation. Now, a relation can be of multiple types. Correspondence or mapping. Yes, absolutely, Akash. Yeah. So any sort of a mapping that happens can be categorized into few different forms, like each of them going to one of them. This is called one-to-one mapping. This is called many-to-one mapping. A and B going to the same one. So many going to one, many-to-one mapping. One-to-many mapping. A going to many, A going to one also, and A going to two also. And the other is many to many. There are four kinds of mapping that are possible from the set domain to the codomain. All sorts can be characterized into these four: one-to-one, many-to-one, one-to-many, and many-to-many. Right? So any sort of a correspondence or any sort of a mapping between two sets is called a relation. Now, how does function enter into the picture? Function is a special type of relation where every element in the domain maps to a unique element in the codomain. Okay. So function is a special type of relation where every element in the domain maps to a unique element in the codomain. So if, for example, A is going to the value 1, it cannot simultaneously go to any other value. A will go to a unique value in the codomain, not multiple values. So a function is a special type of a relation or is a special type of mapping where every element in the domain maps to a unique element in the codomain. Am I understandable? Am I clear? If I am, then please raise your hand. Therefore, you will be able to understand this, that only the mappings 1 to 1 and many to 1 is a function. All other mappings like 1 to many and many to many, this is only a relation. But not a function. Understood? Understandable? If it is okay, then please raise your hand. This can be one example of a function. A going to 1, B going to 2, C going to 4. Right? So this is an example of a function. Right? Now, अभी एक बहुत valid question आ रहा है already in the chat box. Sir, this is codomain. So what is the range? Can anyone tell me what is range? Can you put your answer in the chat box? If this is the codomain, what is the range? Range क्या होता है? What is the difference between codomain and range? Please put your responses in the chat box. I want to see क्या आपको लगता है. Range is all possible value. Then what is the difference between codomain and range? Codomain is fx. All images are codomain. Okay. Put your responses in the chat box. I'm giving you an opportunity to do it. Do it. All right. So the responses are subset of codomain. Codomain is fx. All images are in the codomain. Elements of codomain that have a pre-image, which are linked. Range is subset of codomain. Set of codomain is range. Set of codomain is range. Okay. Then what is the difference? Range is a unique value that we get after substituting domain values in the function. Range is subset of codomain. Range is subset of codomain. Here in this example, 1 to 4 is the range. Okay. Thank you so much for participating. Swarna, Shayantika, Shomili, Kathir, Pratibha, Purbita, Anushka. I'm missing out a few of you, but thank you so much for your responses. So the part in the codomain that are mapped. Okay. So in this example, as one of you have pointed out, 1 to 4 is the range. All elements in the codomain that are mapped, okay, that have a pre-image in the domain, okay, all elements originating is called the element in the domain, and after the mapping, this number 1 is called the image of A, 2 is called the image, 4 is called the image, and for this image, A is called the pre-image. Okay, this is called pre-image, this is called image. Image. Okay, image, pre-image. So all the elements that have a pre-image, all the elements in the codomain that have a pre-image constitute the range. As simple as that, right? So, as many of you have already pointed out, range is always a subset of codomain. And basis this definition, whether range is equal to the codomain or not, gives us something called into onto function. So whenever the range is equal to the codomain, that is, each and every element in the codomain is mapped, each and every element in the codomain is mapped, or each and every element in the codomain has a pre-image in the domain. When range is equal to the codomain, it's called an onto function. When the range is a proper subset of the codomain, it's called an into function. So our example here is an into function. Why? Because 1, 2, 4 is the range, 1, 2, 3, 4 is the codomain. So at least one element in the codomain is not a part of the range. This is an example of an into function. If all of them would have been mapped, then it would have been an onto function. Into onto, onto into. Okay? So range equal to the codomain, onto. In all other cases, into. Simple. Very simple. Okay? Right? Sir, example. Okay? Example. You must see this kind of a framework whenever you see a function question, especially in these entrance examination. This first set of all real number is the domain, and the second set of real number is the codomain. And if the function fx is equal to, say, x square, okay, so x square will obviously take only greater than equal to 0 values. Hence, range in this example is all x greater than equal to 0, or the range is equal to 0 to infinity. Okay. Whereas the codomain is a set of all real numbers. So range is this, codomain is minus infinity to plus infinity. Therefore, what kind of a function is this? It's an into function. Example. Some of you were asking, sir, एक एग्जाम्पल दीजिए फंक्शन से इनटू कैसे हमें दिखता है. ये रहा. अब आपको शायद अच्छे से दिख गया. वेरी गुड. So this is an into function. R to R, fx is equal to x square. Range is only positive values, including 0. Codomain is the set of all real numbers. So into function. Very similarly, fr to r. Okay, what kind of a mapping is this? Some of you are asking me this. You tell me what kind of a mapping is this? This is a function. What kind of a mapping? 1 to 1 or many to 1? Put it in the chat box. Another example, fx is equal to x cube. What kind of a mapping is this? X square, what kind of a mapping is this? Put it in the chat box. 1 to 1, 1 to 1, many to 1, many to 1, many to 1. Perfect. Why are some of you saying 1 to 1? Minus 2 square is equal to 2 square is equal to 4. So multiple values going to the same value. Obviously, it's a many to 1 mapping. So fr to r, fx is equal to x square. What kind of a mapping is this? This is many to 1 and into function. Okay. Now some of you are saying, yes sir, many to 1. अब तो question का solution भी खत्म हो चुका है. fr to r, domain, codomain. Okay. Here, can you please tell me what kind of a function is this? Is it a one-to-one function or a many-to-one function? Secondly, is it into or is it onto? Please tell me, put your answer in the chat box. Do it now. Right. Thank you so much for your responses. So, what is it? Most of you have answered this correctly. This is a one-to-one mapping. Okay. -3 cube will be -27 and 3 cube will be equal to 27. Each and every value will go to a different value in the codomain. Also, x cube will lie between -infinity to +infinity, which is also equal to the codomain. Therefore, onto function. So what kind of a mapping? One-to-one mapping. What kind of a function? Onto function. It's an onto function, right? X cube can take any value between -infinity to +infinity. If you want to see it with the graph, it's quite easy to see that as well. If I draw the graph, look like something like this. Coming from -infinity, going to +infinity, taking any value in the real number line. Okay. Therefore, onto. Okay. So an example of a function which is one-to-one and onto. Multiple examples. Fx is equal to x. That's also onto. Okay. Fx is equal to x minus 2. This is also one-to-one and as well as onto. Please understand, x takes all real numbers. X minus 2 will also take all real numbers. Okay. Right. Now, next, let's go into how to find domain of a function. So if supposing they tell you that fx is equal to root x, domain basically means all values of x for which the function is defined. All values of x for which the function is defined gives us the domain. So if a question asks you fx is equal to root x, What is the domain? The domain is under root. I can't have a negative number. So the domain is x greater than equal to 0. Okay, this is the domain. If they would have asked fx is equal to root over x minus 3, so x minus 3 has to be greater than equal to 0. That means x has to be greater than equal to 3. This will be the domain. Here, this is the domain. What if they ask you fx is equal to x by 3x minus 2? Denominator cannot be equal to 0 because anything by 0 is undefined. Anything divided by 0 is undefined, right? So here 3x minus 2 cannot be equal to 0, or x cannot be equal to 2 by 3. Okay, so what will be the domain? Domain will be equal to the set of all real numbers except the value 2 by 3. Set of all real numbers except the value 2 by 3. You can write it as minus 2 by 3, or you can write it like this, except 2 by 3. Okay. Okay. So all values except 2 by 3. तो डोमेन आपको मोर और लेस समझ में आ गया है. एक दो प्रॉब्लम्स को करते हैं. वंस यू टेक अ लुक एट दोस, you will be able to get a better picture of how we are supposed to find out the domain. चलिए क्वेश्चन को देखते हैं. ISI 2003 question number 12. Okay. ISI 2003 question number 12. Please take a look at the question. I'm activating the poll so that all of you will be able to vote for your answer A, B, C, or D. Make an attempt at the question. I'm just activating the poll in a couple of minutes. Right. Thank you so much for your responses. I'm ending the poll in 5, 4, 3, 2, 1. Ending the poll now. Sharing the results. Okay. So multiple ways of doing this. Okay. We'll do it in one of the ways. So let's go on the whiteboard. Root over x square minus mod x plus 1 by root over 9 minus x square. Okay. This is what we have. Now, first, we deal with this. X square minus mod x has to be greater than equal to 0. Or in other words, x square has to be greater than equal to mod x. Now, where will this happen? You can see it by looking at the graph. You can see it by multiple other ways. Mod x is like this. X square will look like this. Both are equal at the value -1 and +1. And you'll notice that x square is greater than equal to mod x when x is less than equal to -1 or when x is greater than equal to +1. Okay. Next, let's take a look at this. 9 minus x square has to be positive. Why positive? Equal to 0 also will not suffice. Under root, so it has to be positive. Equal to 0 will make it 1 by 0 undefined. That means x square less than 9. That means x has to lie between -3 and +3. Okay. X has to lie between -3 and +3. So this should hold and this should hold. Therefore, x less than -1. Okay. So if I combine this and this, what do I get? Obviously, I need to take whatever is common between the two. So -3 to -1, closed interval, and or union 1 to 3. This is my answer. Is it given that x is greater than equal to 0? No, it's not given. So what should be the answer? Answer is none of the above. Majority of you have marked B. I don't know why. Even 1 will suffice. Look at this. If I put x is equal to 1, this is 0. Plus 1 by root over 9 minus 1, which is basically 1 by root 8, which is defined. So even at x is equal to 1, it will hold. X is equal to -2 also it will hold. Right? So it will hold for these values which are not included in this. So B is not the answer. Answer is D. None of the above. I hope this is okay and clear. If it is, then please raise your hand. Sure, I'm showing you the working once more. Slowly you'll have to get used to graphing. थोड़ा ग्राफ करने में used to होंगे, तभी आगे आगे बढ़ेंगे. Okay, right. Okay. Finding range. Now finding range for any function can happen in, again, multiple ways. One is simply simply by observation. Simply by observation, like fx is equal to x square. By observing, you know that x square can never be negative, so the range has to be 0 to infinity. Okay. Finding out inverse of a function. Okay, and then domain. Finding inverse and then find the domain in order to find out the range. So if f is say equal to x square minus 3, okay, it can be done by observation, but if I want to find out in the other way, so what do? Y is equal to this. Now find out x in terms of y. So from here, x square is equal to y plus 3. X is equal to plus minus root over y plus 3. So what is the domain for this? The domain for this is basically y plus 3 has to be greater than equal to 0, or y is greater than equal to minus 3. Therefore, range has come out to be minus 3 and above. By looking at this, you can also do it in this way, x square minus 3. Okay, x square minus 3, and x square has to be greater than equal to 0. Therefore, lowest value is minus 3 and upper value is infinity. You can think about it in any way. This is the other way, wherein I find out inverse of a function. What is inverse of a function? Inverse of a function is basically to find out x in terms of y, which is basically f inverse y. And then find out the domain. So I have y in terms of x, find out x in terms of y, and then find out the domain of that function. Okay, that will give me the range. Last but not the least, the quadratic approach. Now, what is the quadratic approach? Quadratic approach is basically whenever I have a y is equal to some sort of x, convert this into a quadratic. Okay, so if possible, convert it into a quadratic. If it happens, amazing, well and good. So you'll get something like this: a x square into some y minus 3 plus some x into y plus 5. Is equal to 0. Now, if I write this as a quadratic in x, okay, forget about it. If I write this as a quadratic in x, right, I know that this holds for any real x. That means the discriminant is greater than equal to 0, which is basically y square minus 4 into a. A is y minus 3 into c. And then you solve it. This inequality gives us a range of y values. So what I do is y is equal to fx, convert this into quadratic. Since this holds for any real x, find out the discriminant that has to be greater than equal to 0. This inequality, when you solve, you'll get a particular range of y. That then you substitute here. Okay, see whether it is holding for all the values of y. If it is, then that will give me the range as well. This y basically gives me the range. You just have to check for a few values. That's it. Okay. So there are multiple approaches in order to find out the range. One is the observation, one is the inverse approach, and the other is the quadratic approach. We'll take a look at a few of these approaches right now. Okay. So देखते हैं. Same year ISAT 2003, question number 13. 13 को देखिए. Question is in front of you. Please answer in the poll. ISI 2003, question number 13. Do it. Okay. Sure. Thank you. I'm ending the poll now. इसको क्वाड्रेटिक वाले अप्रोच से करेंगे. Some of you were asking कि सर क्वाड्रेटिक वाला समझ नहीं आया अच्छे से. इसको क्वाड्रेटिक की अप्रोच से करेंगे, आपको समझ में आ जाएगा. काफी सारे तरीके हैं. सबसे पहला तरीका है बाय ऑब्जर्वेशन. हाउ डू यू डू इट? अंडर रूट, it cannot be a negative number, it can only be positive. The range has to go from a positive number. Okay, and try to graph this. Minus 4x square plus 4x plus 3. Try to find out the maxima or the minima here. You'll notice that this will be inverted U shape. You get a maximum value somewhere. Maximum value can be anywhere. Okay, you get a maximum value somewhere, and the value of f for this maximum value from 0 to this value, that will be your answer if you want to do it by the observation or by finding out the maxima and minima for this. Okay, the other approach is the quadratic approach. Minus 4x square plus 4x plus 3. Okay, square it. Go on to the other side. 4x square minus 4x minus 3 plus y square. Okay, this is a quadratic in x. Discriminant has to be greater than or equal to 0 because this is a quadratic where the roots are real. Roots are real का मतलब है discriminant greater than or equal to 0. B square minus 4ac greater than or equal to 0. 16 minus 4 into a into c. It's minus 3 plus y square, hence I'm making it positive. Okay? 16 basically cancels out. Okay. What am I left with? I'm left with 16 common, 1 plus 3 plus y square. So it's like this, minus 3 plus y square. So this will be basically, sorry, 3 minus, this will also be 3 minus. Okay. So this will be 4 minus y square greater than or equal to 0 or y square less than or equal to 4. That means y will lie between minus 2 to plus 2. Okay. Now, under root, I cannot ever have a negative number. So the range cannot have the negative part. It will only have the positive part, which is 0 to 2. 0 to 2. All right. That is my answer. 0 to 2. Okay. So मैंने क्या किया? Quadratic, discriminant positive. From there I get the range of y. Then I basically observe. Negative तो हो नहीं सकता because it's under root. So under root starts from 0. 0 to maximum value is 2. So 0 to 2 is my answer. That will be the range. All right. Answer, as most of you have marked, none of the above. सही जवाब. ठीक है. Inverse approach, you can't do it here. How do you write it in terms of, if I have y square is equal to minus 4x square plus 4x plus 3, how do I write x in terms of y? Not possible here. It's not possible. That is exactly why I showed you all the three approaches. In some of the problems, only one approach will obviously be valid. Okay. So then in that case, you can apply only that approach. So you should know all the three approaches. Okay. Right. चलिए नेक्स्ट क्वेश्चन को देखते हैं. ISI 2001 question number 4. Just showing. Yeah, I hope all of you are able to see the question. It's on your screen right now. This is ISI 2001 question number 4. ISI 2001 question number 4. This is a question which you can solve in all the three approaches. Okay. Try. I'm sure that you will be able to do it. Make an attempt. Please do it. Please make an attempt. All right. चलिए ठीक है. I am ending the poll in 5, 4, 3, 2, 1. Ending the poll now. Right. Find out the range of 2x square by 1 plus 3x square. देखते हैं. First approach, observation. Okay. +1 -1. Okay. Now, 1 minus 1 by 1 plus 3x square. This will always be a fraction. Maximum value will be 1 when x is equal to 0. Okay, if x is equal to 0, this is equal to 0. Two by 3 into 0, which is 0. Okay. As x is going to infinity, y will be equal to, y will be going to 2 by 3 into 1 minus 0. As x is going to infinity, 1 plus 3x square is going to infinity. 1 by infinity is 0. So going to this, therefore, it's going to 2 by 3. That basically means 0 to going to 2 by 3, open interval. Second approach. Find out the inverse. Okay. Okay. 1 by x square is equal to 2 minus. Correct? Yeah. X plus minus root over y by 2 minus 3y. Now, inside part has to be positive. That means either both are negative. How can y be negative and greater than 2 by 3? Not possible. Therefore, both have to be positive. Y less than 2 by 3 and y greater than equal to 0. Combine. How I multiplied by 2 by 3? I wanted a 3 above. यहाँ पर 2 है ना, तो 2 को कॉमन ले लिया, 3 से डिवाइड किया तो 3 को लिख दिया. That's it. काथिर. And then I added one and I subtracted one. Then I solved it. This is the observation way. Okay, observation will always be very, very unique. Each and every problem it will be unique. This is the inverse way, wherein I find out the inverse. Then I find out the domain for this. Domain is under the root, it has to be a positive number. Now, either both numerator and denominator are both negative, but both negative is not possible. So both are positive. Both are positive will mean y less than 2 by 3 and y greater than equal to 0. So between 0 to 2 by 3. Again, I got the same answer. Last but not the least. quadratic approach. Okay. Three x square y plus y minus 2x square is equal to 0. X square common, 3y minus 2 plus y. B square minus 4ac greater than equal to 0. There is no b here. Minus 4 into c into 3y minus 2 greater than equal to 0. 4 cancels out. Y into 3y minus 2 less than equal to 0. Negative number, I make it positive and hence I invert the inequality. 0 to 2 by 3. Y will be negative in between the two and positive in the other two ways. Positive, negative, positive. Therefore, y has to lie between 0 to 2 by 3. Now, 2 by 3, if I substitute in this equation, 2 by 3, if I substitute in this equation, y is equal to 2 by 3, x square into 0 plus 2 by 3 is equal to 0. So I'll get 2 by 3 is equal to 0. Does this make any sense? It doesn't make any sense. So y cannot be equal to 2 by 3. It's less than 2 by 3. So what I did was quadratic, b square minus 4ac greater than equal to 0. Inequality in y between 0 to 2 by 3. Check with the original equation. Checked at 2 by 3 it is not holding. So this is what the answer will be. Whichever approach you take, the answer will obviously be the same. The answer is 0 to 2 by 3 open interval. 2 by 3 is never achievable. Infinity is only a concept. If x is going to infinity, x is 1 by 1 plus 3x square is going to 0. It can never be equal to 0. This is going to 0. कभी भी 0 से equal नहीं है. Okay. Right. Okay. ठीक है. Now let's talk about slide of inverse method. Okay. Take a look at inverse. Next, we'll talk about inverse of a function. Inverse of function क्या है? Domain, codomain, back domain. So function is basically a mapping which originates in the domain, ends in the codomain. Inverse is the journey of going back. So if A was going to 1, B was going to 2, C was going to 3. 1 is going back to A, 2 is going back to B, 3 is going back to C. Okay. A going to 1, B going to 2, C going to 3, 1 going back to A, 2 going back to B, 3 going back to C. Okay. So this is inverse in short. Okay. So if it would have been like this, 2 would have gone to C also. So as you can see, if F becomes many to 1, F inverse becomes a 1 to many. It becomes a 1 to many, right? This is many to 1. F inverse becomes 1 to many. F is 1 to 1. F inverse remains 1 to 1. F inverse is also 1 to 1. ठीक है? Properties of inverse. Number 1, F inverse will be continuous if F is 1 to 1. You can see that F inverse will only be defined continuously if F is 1 to 1. नहीं तो F inverse becomes 1 to many, right? So it's not defined. F inverse derivative is 1 by F dash. So derivative of the inverse equals inverse of the derivative. Inverse of the derivative basically means 1 by F dash, and derivative of the inverse is F inverse dash. F of F inverse X is equal to X. Okay, standard result. It's a standard result, very standard. Because if I take this F here, it becomes F inverse, right? By the graph. F inverse. F inverse is mirror image of the function F around the 45-degree line. So if this is my F inverse is the mirror image of this, because X comma Y becomes Y comma X. So it is nothing but the mirror image. Very, very simple. XY, this is YX. So F inverse is nothing but the mirror image of F around the 45-degree line. Okay? These are a few things which I wanted to share with each of you. अब एक दो सिंपल सा क्वेश्चन करते हैं इनवर्स ऑफ अ फंक्शन पे. This is extremely easy. What is the answer to this? Question number 6. Put your answer in the poll. I'm giving you 1 minute. Do it. All right. I'm ending the poll now. Trapped. Okay. ISI 2001, question number 6. Y is equal to 1 by x. X will be equal to 1 by y. This is the inverse. Therefore, the answer is D. That's it. There are so many of you who have marked X. I don't know why you've marked X. Inverse is going back, right? So if I am from 2 to, I'm going to half, 1 by x, right? From half, I need to go back to 2. So what do I need to do? 1 divided by half, which will give me 2. So if I go from x to 1 by x, if I have to go back to x, I need to do 1 divided by 1 by x, right? So the inverse is 1 by x. And it's very easy. Y is equal to 1 by x is equal to 1 by y. So this is the functional form of inverse. This is the functional form of inverse. Gx will be equal to 1 by x. D is the answer. Okay. Alokita. Okay, what is the problem? Which area was the problem? You need to find out inverse. Inverse is basically going back to what we started off with, right? So if I'm going from x to 1 by x, if I have to go back to x, what do I need to do? I need to do the same thing, 1 divided by 1 by x, right? So 1 by x will be the inverse if I need to go back. So if I need to go back from half back to 2, I need to do 1 by half. So 1 by x is the inverse. Okay. Question number 1, ISI 2006, question number 1. Please put your answer in the poll once more. Do it. Please do it. Right. Okay. This is ISI 2006, question number 1. I'm ending the poll now. Okay, let's try and do this. ISI 2006, question number 1. Fx is equal to this. F of 2x by 1 plus x square is what I need to find out. Fx is log of 1 plus x by 1 minus x. That's given to us in the question. X is lying between 0 and 1. I need to find out f of 2x by 1 plus x square. Okay. F of 2x by 1 plus x square is basically log of 1 plus 2x by 1 plus x square. This basically cancels out. which is nothing but so log of 1 plus x by 1 minus x is what my f is. F of 2x by 1 plus x square is equal to log of 1 plus 2x by 1 plus x square by 1 minus 2x by 1 plus x square, which is equal to log of this, which is equal to log of this. Simplify, you'll get this. Answer is A. ओके ठीक है सही है so that is that. Let's do one thing. Let's stop here for today. I'll continue on with increasing decreasing functions. Then we'll go into basically what are homogeneous functions, convex concave functions, and so we'll do all of that in the next class. Okay, and then after we finish this, we'll go into limits. Right. Thank you so much, everyone, for being a part of the class today. I hope that functions is now easier and a better topic in your brains. And I hope that you enjoy the class as much as I did. Right. Thank you so much. Till we meet next on Thursday. Be well and stay safe. See you in the next class. Bye-bye.